Hello, this is Quan Lu, and today we're going to be talking about charge tapes again. So our goal of this is to find out how much charge is on one piece of tape that we charge up. It's going to be the same tapes as last time, and this time we're going to model each piece of tape as a line of point charges instead of a single point charge. The two pieces are still separated by distance d, and tape B is floating on top of tape A. We're going to use Newton's second law to calculate the weight of each tape, mostly just tape B. And we're going to use Coulomb's law to calculate the charge from each particle onto each other particle. So we got to use superposition, the concept of superposition, to calculate the actual net force on each piece of tape. And our results were that the piece of tape had about 2.46 times 10 to the negative 8 coulombs of charge, which is greater than I previously assumed from Lab 1. In Lab 1, we measured that the distance required to float tape B on top of tape A was about 2.3 centimeters. And we also saw that two U tapes repel each other, so they're of the same charge. Two U tapes are attracted, or any U tapes are attracted to neutral objects, such as my hand, and they are also attracted to a negatively charged plastic pen. This is crucial because it tells us that U tapes have to be positively charged because opposites attract. And the negatively charged pen had to be attracted to the U tape only if the U tape was positively charged. So, let's take a look at this. Last time I determined that Q was 1.07 times 10 to the negative 8, and that was too little for this model. Let's look at this magnitude. It's about 2 times less. And so I played around with it a bit, and I came up with Q being 2.459 times 10 to the negative 8 coulombs, and that gave us about equal magnitude for electric force in white and gravitational force in yellow. And our system is the top tape, and the surroundings, the top tape is the red dots, and the surroundings are the bottom tape and the earth. So how did we do this using code? The green vectors are on each individual dq of the top tape, and it sums up each individual force from each blue dot, and that's in this lower loop, and we sum them all up and we add them together and put it where the red dot is. So then we sum up all these greens to find the white one, and they have some x components, but they each cancel out to have just a y component. The yellow tape, or the yellow line, is the yellow vector is just negative m times g. So our assumptions that we made are that the U tape had about the same amount of charge and that it's evenly distributed along the length of the tape. But some systematic errors come from the fact that you can't really make a U tape that's the exact same, and so that means Q is probably not going to be the exact same. And U tapes also just lose charge over time. Some model discrepancies are that the tapes probably don't have the same amount of charge, and that they are not really a line of point charges. It's a step up from a single point charge, but a more accurate model might have a sheet of point charges in a plane. So what if each of the tapes were treated as a single point charge? Then we're back to the old model, Lab 1, and from Lab 1 we calculated 1.07 times 10 to the negative 8 coulombs, whereas in the new model we got 2.46 times 10 to the negative 8 coulombs. Obviously this is a pretty big discrepancy. But the new model is probably more accurate, since the new model has a line of point charges, which is just more close to how it is in real life. So these estimates differ because of that. The fact that we're using a line point charge model rather than a single point charge.